Then question number 3 is still a sequences and series, but they're telling us we must consider this quadratic pattern. Can we show that the general term of this pattern is given by this? So remember, by virtue of definition, quadratic pattern must have two differences. Okay, so we know that for us to move from 4 to 7, that's a plus 4. Sorry, from 3 to 7, plus 4. And then that is a 5, which means our second difference here is just a 1. So this one is being represented by 2a. Divide both sides by 2, which means a is a half, okay, which we have it here. And then we know that 3a plus a b must give us the first term of the first difference, which is a 4. But our a is a half, so which means b is going to be 4 minus 3 over 2. That is 5 over 2. Okay, I'm replacing a with a half, which will be 3 over 2, plus a b must give us a 4, and then I transpose. Okay, so that's our b, which is here. Now let's confirm if there is really no c. If I get a plus b plus c, I should be able to get this first term, which is a 3. So a is a half, b is 5 over 2, plus c is equal to 3. So this can be simplified to a 3, and the 3 cancels, c is a 0. So therefore, Tn becomes a half n squared plus 5 over 2n. So the aim of this question is just to really check if learners know how to determine the a and the b and the c. Basically, they were not asking for the Tn because they have already given it to you. Okay, then 3.1.2. What number must be added to the Tn minus 1 so that the Tn is that? Wow. Now, when you look at this question, okay, it looks tricky, but it is simple, very direct. Remember, if you talk of Tn minus 1 and Tn, it's like these are consecutive terms that are just one after the other. Let me just write this, that's on the next page. This is 3.1.2. Okay. 3.1.2. So we're saying we started with a 3, a 7, a 12, and so on and so forth. So we're going to have a scenario where we have a term that is Tn minus 1, and then we also have a term that is 13,527. 13,527. Now the question is asking us what number must be added. Initially, the first differences are all about additions. Why am I having a 5 here? This is a 7, and then a 12. So this is a 4, and then that's a 5, and so on and so forth. So we are just adding. In other words, which number do we add here to give us that? So 2 ways to do this. The first approach is for us to get the position of this 13527. Okay, for me to get that, I'll apply my Tn, where we said it's a half n squared plus 5 over 2n. Then I'm going to equate it to 13527. So this is a quadratic, so it's a half n squared plus 5 over 2n minus 13527 is equal to 0. If I use my quadratic formula, a is going to be a half, b is going to be 5 over 2, c is going to be negative 13527. Okay, this is the, I don't know, I will call it the longer approach. Then when I use the quadratic formula, I'm getting n to be either negative 61 or n to be a 61. But remember, positions, no, not 61. Who is mentioning 61? It's 162 and negative 162. Okay, so negative 162 and a positive 162. We can confirm that again so that we are on the same page. Minus 13527. What do we get? That's negative 167 and then a positive 162. Now remember, position of terms can never be negative. Okay, so this is not applicable. This negative 167. So what we are left with is 162. Now, if we have 162 as our position, the number that they are talking about here will be 161. Now that's the position will be 161 for the Tn minus 1. Okay, and if that's the case, just get this 161, substitute it into the Tn. Let's get the value and let's do the subtraction. So I'm going to say 161 is going to be a half times 161 squared plus 5 over 2 into 161. Okay, so I'm ending up with 13. What's happening with my pen? 13363. And then the difference is going to be 13527 minus 13363. And this gives me 164. So this is the answer that they want. This is the number that must be added to the Tn minus 1 to give you that. There is a shorter way. There is a shorter way. And the shorter way is to use the arithmetic pattern. Okay, the first difference is if we can get this number straight away. Straight away. So how do we go about that? It's of course going through this quadratic, and then you get your 162 as the option. Then what that means is that in this position of the arithmetic, the position of this one is going to be 161. Okay, then if I look at my Tn, you know that it's a plus n minus 1 into d. Our first term was a 4 minus n minus 1. Our common difference was a 1. When you simplify that, you'll just have n plus 3. Okay, so remember we said our Tn is 161, the position, or not the position, the term itself. So that's gonna be 161, that's 4n plus 3. He said 162, 161, that's correct. I don't know how I'm failing to get the 164, but it should be around that. No, it's already done. It's already done. Because what's going to happen is that we're looking for the Tn in a position of 161. Okay. So we're saying Tn. Okay. Tn is going to be, apologies guys, my pen is acting up. Okay. So we're saying the position is 161 plus a 3, and then that gives us 164 as our answer. Okay, so for as long as we get the position of the 13, 5 to 7, and then the rest is just an application. Okay, so that is 3.1.2. 3.2, they are telling us that we are given an arithmetic sequence with T1 as 8, T2 as 11. They want us to calculate the value of n if Tn is 41. So this is more like